আজকের টপিকটা হচ্ছে মোশনাল ইএমএফ। ঠিক আছে, আগের দিন যেটা শিখলাম যে ইফ দেয়ার ইজ এ চেঞ্জ ইন ফ্লাক্স, মানে যদি ডেল্টা ফাই তৈরি করতে পারি, সো রেট অফ চেঞ্জ অফ ফ্লাক্স মানে ডেল্টা ফাই বাই ডেল্টা টি যদি করতে পারি, তো দ্যাট উইল গিভ দ্য ইনডিউসড ইএমএফ। এটা বের করেছিলাম। ইনডিউসড ইএমএফ জেনারেট হয়েছে মানে দেয়ার মাস্ট বি সাম কাইন্ড অফ কারেন্ট ইজ বিং ফ্লোয়িং। এবার কারেন্টটা বের করা শিখেছিলাম। ডিরেকশনটা কোন দিকে হবে সেটা লেন্স ল বলতো, আর ম্যাগনিটিউডটা বের করার জন্য ফ্যারাডেজ ল। আমরা এখানে ফ্লাক্সটাকে চেঞ্জ করে কারেন্টটা তৈরি করি। নাও কারেন্টে যেমন তৈরি হয়েছিল তাহলে ইন্ডিউসড ইএমএফ তৈরি হয়েছিল, এবার আর এক ধরনের ইএমএফ তৈরি করবো, দ্যাট ইজ ডিউ টু মুভমেন্ট অফ দ্য কন্ডাক্টর। হ্যাঁ, দ্যাট ইজ কল্ড দ্য মোশনাল ইএমএফ। সো যদি এরকম একটা কন্ডাক্টর থাকে, হ্যাঁ, ইন দ্য প্রেজেন্স অফ এক্সটার্নাল ম্যাগনেটিক ফিল্ড, ধর বললাম এখানে একটা বি তৈরি করা হয়েছে আন্ডার দ্য প্রেজেন্স অফ দ্য এক্সটার্নাল ম্যাগনেটিক ফিল্ড, নাও আই এম মুভিং দ্য কন্ডাক্টর উইদাউট নট চেঞ্জ, মানে আমি বিটা কোনো চেঞ্জ করছি না, অনলি থিং ইজ দ্যাট কন্ডাক্টর ইজ নাও মুভিং। সো whenever the conductor is moving with certain velocity, তো কন্ডাক্টর মুভ করছে মানে একটা ভি রয়েছে। তো নাও অ্যাক্রস দিস কন্ডাক্টর এ পোটেনশিয়াল ডিফারেন্স ইজ বিং ক্রিয়েটেড। এই পোটেনশিয়াল ডিফারেন্স যেটা তৈরি হলো দ্যাট ইজ কল্ড দ্য মোশনাল ইএমএফ। বোঝা গেছে? বের করা হয় কেমন করে? এই এপসিলনটাকে বলা হচ্ছে ডিভিএল। এই এপসিলনটা মানে যেটা আমার ইএমএফ যেটা তৈরি হবে ডিউ টু মোশন অফ দ্য কন্ডাক্টর। রডটা মুভ করছে, তাহলে মোশন অফ দ্য কন্ডাক্টরের জন্য আমি এইভাবে অ্যাকচুয়ালি ফর্মুলাটা এরকম নয়, ফর্মুলাটা হচ্ছে আমার এরকম। আমার একটা ক্রস প্রোডাক্ট করতে হবে এখানে, ভি ভেক্টর ক্রস বি ভেক্টর ডট এল। হ্যাঁ, এটা যদি করি দ্যাট ইজ দ্য অ্যাকচুয়াল এক্সপ্রেশন। তাহলে এবার তুই বল আমাকে, ভি ক্রস বি যদি করে দিই তাহলে কোনটা হবে, কোন দিকটা হবে? ভি ক্রস বি যদি করি তাহলে পামের ফেসটা কোন দিকে থাকছে? আপওয়ার্ড থাকছে। তাহলে আপওয়ার্ডটা হয়ে যাবে হাই পোটেনশিয়াল সাইড, হ্যাঁ, আর লোয়ার সাইডটা হয়ে যাবে লো পোটেনশিয়াল সাইড। সো দিস রড উইল অ্যাক্ট অ্যাজ এ ব্যাটারি। এই ব্যাটারিটা কেমন করে দেখাবো? এই ব্যাটারিটা দেখাবো যে এই হাই পোটেনশিয়ালটা এইদিকে রয়েছে, লো পোটেনশিয়াল এইদিকে রয়েছে, মানে রড ইজ অ্যাক্টিং অ্যাজ এ ব্যাটারি হুজ ইনডিউসড ইএমএফ অর মোশনাল ইএমএফ ইজ বেসিক্যালি ইকুয়ালস টু বিভিএল। বুঝলেন? এইভাবে দেখতে হবে। তাহলে আমরা অ্যাকচুয়াল ফর্মুলাটা হচ্ছে ভি ক্রস বি, ভি ক্রস বি ডট এল ভেক্টর। এলটা কি? এলটা হচ্ছে লেন্থ অফ দ্য কন্ডাক্টর। এইভাবে বুঝতে পারবো যে কোন দিকে আমার হাই পোটেনশিয়াল সাইডটা হয়েছে, কোন দিকে লো পোটেনশিয়াল সাইডটা হয়েছে। তো হচ্ছে কেন এই জিনিসটা, সেটাকে বোঝার চেষ্টা করি যে হোয়াই দিস ইজ হ্যাপেনিং। সো আমি ধর বললাম যে আন্ডার দ্য প্রেজেন্স অফ এক্সটার্নাল ম্যাগনেটিক ফিল্ড এ কন্ডাক্টর ইজ মুভিং উইথ এ স্পিড অফ ভি। ভি নিয়ে মুভ করছে, এইদিকে বিটা ফিক্সড রেখেছে, এটা চেঞ্জ করছে না, কিন্তু বি নাম্বারটা কনস্ট্যান্ট। এই বি নাম্বারটা কনস্ট্যান্ট রয়েছে। সো ইনসাইড দ্য কন্ডাক্টর আমরা কি ধরবো, যে দেয়ার আর লটস অফ ফ্রি ইলেকট্রনস। ধর বললাম যে এইখানে একটা ফ্রি ইলেকট্রনকে দেখছিস, সো দ্য ফ্রি ইলেকট্রন ইজ মুভিং ইন দিস ডিরেকশন। এর ভেলোসিটি এইদিকে রয়েছে। ইফ দ্য ইলেকট্রন ইজ ফ্রি টু মুভ, তাহলে বিকজ অফ দিস ইলেকট্রন যখন আমি রাইটের দিকে মুভ করাচ্ছি আন্ডার দ্য প্রেজেন্স অফ ক্রস ম্যাগনেটিক ফিল্ড, তুই ভাবলি তোর কাছে একটা সিঙ্গেল ইলেকট্রন রয়েছে হুইচ ইজ মুভিং টুয়ার্ডস রাইট আন্ডার দ্য প্রেজেন্স অফ ক্রস ম্যাগনেটিক ফিল্ড। সো ইন হুইচ ডিরেকশন দ্য ইলেকট্রন উইল ফিল দ্য ফোর্স? কোন দিকে ইলেকট্রনটা ফোর্স ফিল করবে? হ্যাঁ, ডাউনওয়ার্ড ফোর্স ফিল করবে। সো ইলেকট্রন উইল ফিল এ ফোর্স ইন দ্য ডাউনওয়ার্ড ডিরেকশন। এই ফোর্সের ম্যাগনিটিউড কত হবে? এই ফোর্সের ম্যাগনিটিউড কত হবে? হ্যাঁ, বি কিউ ভি হয়। বি কিউ ভি মানে বি ই ভি, এইটা ফোর্স ফিল করবে। সো বিকজ অফ দিস ডাউনওয়ার্ড ফোর্স occurring on the electrons, all the electrons are feeling a downward. তাহলে আলটিমেটলি হবে কি, after some point of time I get an electron cloud on the lower side. একটা ইলেকট্রন ডেন্সিটি নিচের দিকে বাড়বে। সো আপার পার্ট অফ দ্য রড becomes less electron. So upper part of the rod becomes positive one. Okay, কেন এটা হচ্ছে? বিকজ there is a deficiency of electron in the upper side. উপর থেকে ইলেকট্রন নিচের দিকে নামার চেষ্টা করছে বিকজ অফ দ্য ম্যাগনেটিক ফোর্স। সো আলটিমেটলি বিকজ অফ দিস ইলেকট্রন চার্জ ডিস্ট্রিবিউশন, ডিফারেন্স ইন চার্জ ডিস্ট্রিবিউশন, আমরা বলবো যে এই জায়গাটা হয়ে গেল হাই পোটেনশিয়াল সাইড, এই হচ্ছে লো পোটেনশিয়াল সাইড, and because of that an electric field will be established within the conductor. Now an electric field will be established, and what is the direction of electric field? Direction of electric field should be downward. Okay, so because of the electric field, now as the time increases, the magnitude of E will increase. Can as the time increases, the magnitude of E electric field will increase. Why? Because as time passes, more and more electron will go downward direction. অনেক বেশি বেশি করে ইলেকট্রন নিচের দিকে নামবে। So that means the negative charge on the lower side will increase. And similarly, the positive charge on the upper side will also increase magnitude-wise. So that means the strength of the electric field will gradually increase. So under the presence of the electric field and also the magnetic field, now the electron will feel two different types of force. One force is the magnetic force that is acting downward. Another force is the electrostatic force that is acting upward. Okay. So now after some point of time, electron will stop to flow. Once these two forces are balancing each other. So upward force is basically E into capital E and downward force is BEV. If these two forces are equal, now at this point of time, what I ensure that the electric field established is equals to B into V. যখন ইলেকট্রিক ফিল্ড ম্যাগনেটিক এটা রিচ করে গেছে, that is now I can say that now electron will stop to flow. Okay. Now, because of this, that is the maximum electric field generated in that conductor, and because of that, there is a potential difference. I want to calculate that potential difference. So, what is E electric field that is developed? That is nothing but the V divided by L number. What is V? V is the potential difference across the conductor, and L is the length of the conductor. Why? Because dVdr. E equals to dVdr. So from that, what I am getting that E number is equals to V by L. Or what we can say, V equals to E into L. Now what is the E is the electric field. Electric field I got value is V into V. So ultimately what I am getting BVL. So this is the potential difference across the conductor when the conductor is moving with the speed V under the constant magnetic field. So this magnetic field is external. This magnetic field is not created by this conductor. So it is created externally. So because of that external magnetic field, now there is a potential difference across this conductor. So that means if I connect this conductor, if I make a closed circuit, now through this circuit, now the current will flow. Why? Because আমি replace করলাম কি, the conductor is replaced by a single battery. So this is a kind of battery. So in order to make the current to flow, the circuit should be closed one. So once I close this conductor with the connecting wire, then only I can feel the amount of current that is being flowing. Okay. So this is the idea of getting the motional EMF. So motional EMF formula wise, it is the formula. It is the magnetic force formula, and corresponding to that, because the magnetic force acting on the electron, ultimately there is a difference of charge and which will create a electric field. Because of that electric field, now electrons are pulled backward, and ultimately one point will come when the electron will stop. At that point of time, what is the magnitude of E? That we are noted. এই যে B into V নাম্বারটা হলো, that is the electric field, that is the maximum electric field. Okay, initially the electric field number is 0. Once there is no movement of the electron. So with time, the electrons are moving at a faster rate. Ultimately, more and more electrons will move downward. Ultimately, one point will come when the electric field will reach a saturation value, that is the BV. At that point of time, what I can say, the electron will stop to flow, and at that point I measure what is the corresponding potential difference. That difference is called the motional EMF. Okay, that is BVL. So mathematically, what you can say that total force acting on the charge. So let us say any charge particle is there. So on this charge, what is the total force? So total force over here is because of Lorentz force. Why? Because on this particle, both the electric field and magnetic field are acting. So on this particle, both electric field and magnetic fields are acting. So net force is 0. Net force is 0. F net, that is equals to Q into E vector. That is the electric force plus Q into V vector cross V vector. This is the magnetic force, and that should be equals to 0. Okay, that should be equals to 0. Why? Because the charged particle is acted upon by two different forces. One is the electric force and the magnetic force, and these two forces should balance each other. So what I am getting? So if I say E vector, that should be equals to V vector cross V vector. Omitting the negative sign. Why? Because direction is opposite. So correspondingly, dV vector. dV is what? dV is the small change in the potential difference. That can be written as equals to E vector dot dl vector. dV dl equals to E. So dV equals to E dot dl. So ultimately what I am getting, that is equals to V vector cross V vector dot dl vector. Okay. Or what we can say, total potential difference V, that is the potential difference, that should be equals to V vector cross V vector dot L vector. So it is called basically the formula is based on the scalar triple product. ultimately answer is in scalar format. Why? V is the potential difference. Potential difference is always a scalar number. So it is called a scalar trivial product. V cross V dot L, and direction of the high potential side will be determined by this cross product formation. Cross product rule থেকে আমরা বের করতে পারবো যে which side of the wire is getting the high potential and which side is getting the low potential. That's why I can draw the battery. So B is the magnetic field, V is the velocity of the rod, length is the L vector. So effect of this basically BVL. Once I am writing as a BVL, that means I am saying that epsilon equals to V vector cross B vector dot L vector. So if I expand this V vector cross B vector, that is equals to VB sin theta. Okay, dot L vector. So now that can be written as BVL when the theta is become 90 degree. Theta is what? Theta is the angle between the V vector and B vector. So in this situation, the velocity is in this direction and B is cross. Okay, can I say theta is 90 degree? So that equation is only applicable when the theta angle, that is the angle between the velocity vector and the magnetic field vector, is 90 degree. Then only I can write equals to BVL. If the angle is different, then you should choose the proper angle. Okay. So that is the potential difference. It is a scalar trivial product. And if any of the two quantity, either B, V or L, is parallel to each other, then let us say I am saying one situation was there, V vector is parallel to B vector. If V vector is parallel to B vector, that means cross product is 0. Cross product is 0. So that means it implies the potential difference is also 0. If I say V vector is parallel to L vector, V vector is parallel to L vector, that means whatever the value of V vector cross B vector that I am getting, that is parallel to the L vector then. না, আমি যদি ধরি যে একটা V vector এই দিকে রয়েছে and B vector তো এই দিকে রয়েছে. Now these two are let us say perpendicular. So V cross B should be this vector. V cross B should be either upward or downward. If I say this is the second cross product vector and that is parallel to the L vector, that is V is along this parallel line. So that means this is the L vector. Let us say L vector is parallel to. So now I have to make the dot product of these two vectors, L vector and V cross B. So angle is 90 degree. So dot product gives 0 result. So that means if V is parallel to L vector, then V vector cross B vector dot L vector, that gives 0. That means again the potential difference is 0. If I say L vector is parallel to B vector, L vector is parallel to B vector, that means if I say this is the B vector, let us say this is the V vector and L is along this direction. So V cross B should be downward direction. Let us say V cross B in the downward direction. Now this downward vector cross product and L vector, once I take the dot, it again gives 0 because perpendicular vector gives the dot product as 0. So again it gives V equals to 0. So that means if any of the two vectors, either V or B or V or L or L or B, if any of the two vectors are parallel to each other, that means what I am getting, the result is 0. Okay, that means there is no potential difference. So in order to make the potential difference, so these any two vectors cannot be parallel to each other. That is the condition. Now, so this is the direction of the induced EMF. So what I am saying, that correspondingly what is the getting, that is epsilon is known as the induced EMF, and that induction takes place because of the motion. Now once the conductor is moving, so V cross B, direction of V cross B is upward. Direction of V vector cross B vector is upward. That means the upward side is the high potential side, lower part of the conductor wire is the low potential side. So this is the representation of the battery corresponding to the conductor. Now let us say there is a rod of length AB whose length is given as L. It is placed under the dot magnetic field. Now the rod is moving at an angle of V0 with a velocity of V0 at an angle of 37 degree. You are asked to calculate the VB minus VA number. Now first do the cross product. Now if the V0 vector is in this direction and V is dot, so V dot B, V cross B, so V cross B will be in this direction. So this is the direction of the V0 vector cross B vector. Okay. So what is the answer? Answer is V0 into B. Why? Because these two are 90 degree. These two are at an angle 90 degree. Now with this V0 cross B direction, now the length of the vector is L vector is in this direction. Now what is this angle? This angle is 53 degree. This angle is 53 degree. Why? Because this is given as 37 degree. Okay, this is given as 37 degree. So you have to take the dot product between the V cross V and L. So ultimately our answer is V naught B into L cos of 53. That is the answer. Now, direction of V naught B is closer to the end B. And if I consider the rod over here, so this is the rod AB. Now V naught B is directed towards the point B. So B is acting as the high potential side, A is acting as the low potential side. So direction of the V cross B vector should be either actually directed towards B or closer to point B. So accordingly, I have to take which one is the high potential side, which one is the low potential side. So in this situation, V naught B vector is closer to our point B. So B is acting as the high potential, A is acting as the low potential. Okay. So this is the way you have to calculate this. So ultimately, this number that I am getting is nothing but our potential difference between B and A. So that is our answer for the V minus VA. Okay. So if I say the rod is moving at an angle theta, in this situation also the rod is moving at an angle theta. Why? Because the direction of the velocity vector and the L vector are not parallel to each other, or not perpendicular to each other. They are making some angle. So if that is the case, that L vector and the velocity vector are at an angle. Now, let us say V naught is making an angle theta with the L vector. So for that situation, you have to take the component of L which is perpendicular to V naught. If I take the component of L, which is perpendicular to V naught, this is this component. So if I say this angle is theta, so if I say this is the rod AB, so perpendicular component will be, let us say, BA prime. So BA prime is nothing but the component of L which is perpendicular to V naught vector. Can I say that? Yes. So what is the length BA prime? BA prime becomes L sine theta. Okay. So now instead of this rod, if I take, there is one rod is there whose length is L sine theta, which is moving with the velocity V naught and under the presence of cross magnetic field B. So again, if I do the V naught cross B, so V naught cross B will be directed towards up. So this point is acting as a high potential side and this point is acting as a low potential side. So this is answer is VB minus VA, that the potential difference between the B end and the A end should be equals to how much? BV into L. Instead of L, write L sine theta. So that will be your answer. Okay. So either I can take the component of L, which is perpendicular to the V naught direction, or I can do it in a regular way. So in a regular way, if I have to do it, so I have to take care first of all the direction of V naught cross B. So once I do the V naught cross B, so it should be in this direction. Now this is the direction of V naught cross B vector. So ultimately this answer is equals to V naught into B. Now this V naught B vector or cross vector is making an angle 90 minus theta with the L vector. So if I say this is L vector and the V naught cross B is in this upward direction. So this is the V naught cross B direction. Now this angle is how much? 90 minus theta. So this angle is 90 minus theta. So it should be equals to how much? V naught cross B dot L. Dot করলে হবে কি cos of 90 minus theta. So ultimately our answer should be V naught B L into sin theta. That is the value of VB minus VA. Okay. So this is the conventional way of doing it. First calculate the cross product direction and then take the dot product. So for that you don't have to take the any component, but in a similar way I can do it in a simple way. If I take the component of L vector which is perpendicular to V naught, you have to take the component of L which is perpendicular to the V naught. And mind it that only when you can apply this formula is that all the points on the rod, are on the same electric, so magnetic field. If all the points on the rod are with the same magnetic field, then only I can apply it. If it is a variable magnetic field, then you have to integrate it. Okay. So in this situation, I can take all the points which are on the rod are acted upon by the same magnetic field, that is the B. Okay, that's why I am applying this formula. Okay. So this is the final situation where I can write this form or BVL prime. What is that L prime length? L prime is nothing but this perpendicular length. Okay. L prime is the component of length between end which is perpendicular to V naught vector. Okay. So according to the velocity direction, you take the component of the L vector which is perpendicular to V naught and accordingly you use that. So simply I am writing the same equation as BVL, but instead of L, I am writing now L prime. Okay. So let us say there is a rod of semicircular section. Rod of semicircular section. So whenever the rod of semicircular section, can I say that all the points on the rod at the same potential, same magnetic field? All the points on the rod are acted upon by the same magnetic field. So that means I can change the rod by a situation where I can connect this by a simple straight wire joining point A and B in this way. Okay. Because A and B at the starting point and the end point, you have to draw it in such a way so that the A and B is becoming straight line. So what is this length? That length is now 2r. Okay. That length is now 2r. So correspondingly, so this is analogous to this situation where there is simple straight wire is there and that is moving with the velocity v naught. Okay. So as all the points are moving with the same speed, so this point is also moving with v naught. This point is also moving with v naught. So I can replace this wire by a straight wire connecting the initial point and the final point. The length of the rod now becomes 2r and now this 2r is perpendicular to v naught. So I can directly apply the potential difference. So V cross B. So if I say this is the B vector direction, so V cross B should be towards our A point. So A is acted upon by a high potential side and B is the low potential side. And V naught cross B vector direction কোন দিকে হবে? V naught cross B towards left. So A is the high potential side. So ultimately what I can say, VA minus VB, that number is equals to V naught into 2R. That will be your answer. Okay. বোঝা গেছে? কেন একটা ওয়্যার কে যদি একটা রিজিড বডি না, so this is the rigid body. So once I am moving a rigid body, so all the points on the rigid body are moving the same speed, and also all the points on the body are under the same magnetic field also. তখনই আমরা এটা লাগাতে পারবো, তখনই এটা অ্যাপ্লাই করতে পারবো, আদারওয়াইজ করতে পারবো না। বোঝা গেছে? কোথায় লেন্থ চেঞ্জ হচ্ছে? বাবা এই যে সেমি সার্কুলার ওয়্যারটা রয়েছে, দ্যাট ওয়্যার ইজ নট চেঞ্জিং ইটস লেন্থ। যখন এই গল্পটা হবে যে ওয়্যার ইজ নট চেঞ্জিং ইটস লেন্থ, অল দ্য পয়েন্টস আর মুভিং দ্য সেম স্পিড অ্যান্ড অল দ্য পয়েন্টস আর আন্ডার দ্য সেম ম্যাগনেটিক ফিল্ড, দেন আই ক্যান রিপ্লেস দ্য কার্ভড ওয়্যার। যদি এই ওয়্যারটা এরকমও থাকতো, হ্যাঁ, এই ওয়্যারটার উল্টোপাল্টা শেপে রয়েছে, নাও আই ক্যান জয়েন দ্য পয়েন্ট এ অ্যান্ড বি বাই দ্য স্ট্রেট লাইন। এই যে লাইনটা তৈরি করলাম, দ্যাট ইজ নাথিং বাট দ্য ওয়্যার। এবার এই ওয়্যারটাকে, এইটাকে তুই ভি নট নিয়ে উপর দিকে টানা, আর এই ওয়্যারটাকে ভি নট নিয়ে উপর দিকে টানা, বোথ আর সেম। Okay. So instead of calculating the same thing for the green wire, I can do it for the yellow wire. বোঝা গেছে? এটাই করা হচ্ছে। কিন্তু এটা ট্রিকটা লাগবে কখন? যখন কিনা প্রত্যেকটা পয়েন্ট আর মুভিং দ্য সেম স্পিড and they are under the same magnetic field. Otherwise they cannot apply. So join initial and the final point by a straight line. This is the effective length. Okay. So this is the effective length. So whatever is the shape of the wire, so আমি যদি ধরতাম যে এই ওয়্যারটা রয়েছে আমার কাছে, so instead of taking that wire, what I am taking, the line joining between the initial and the final point as our wire, and take the component of wire which is perpendicular to V naught. So ধর বললাম যে এই ওয়্যারটা আমার এই দিকে যাচ্ছে V naught নিয়ে, so that means instead of taking this white wire, I am taking the blue wire which is moving in this direction V naught. Okay. Now what is the length? So length should be this number. So this is the vertical length, that is the perpendicular length which is corresponding to the V naught vector. So that should be our L prime number. So ultimately our answer should be V naught into V into L prime. Okay. এটাই করতে হবে। So let us say there is a L-shaped wire. L-shaped wire. So let us say both the length of the wire is L and the entire rod is moving with a V naught velocity. Entire rod is moving with a V naught velocity. And let us also say this angle, let us say this angle is 37 degree. This angle is 37 degree. So for the AC part, if I take the AC part and BC part, can I say that all the points on the wire are moving the same speed? Because it is a rigid wire. It is not changing its shape. So all the points on the wire are moving the same speed, and all the points on the wire are also under the same magnetic field. So instead of taking the L-shaped wire, can I replace by a straight wire like this AB? Yes. So instead of moving this L-shaped wire. Now I am saying the AB wire is moving with the speed V naught in the same direction. V naught direction change করলে হবে নাকি? V naught যা ছিল সেটাই রাখতে হবে. Now what is the length AB? What is the length AB? So if I say that angle is 37 degree and let us say this angle is 53 degree. Okay, this angle is 53 degree. So that it becomes a L-shaped wire. So total angle is 90 degree. So this vertical length should be equal to L sin 37. That means 3L by 5. And this is equals to L sin 53, 4L by 5. So total length is how much? 7L by 5. So total length is 7L by 5. And this rod is moving with the speed V naught and at the presence of dot magnetic field. So first take the V naught cross B. The V naught cross B will be downward. So B is the high potential side and A is the low potential side. So potential difference between B and A is how much? That should be equal to BVL. So B V naught into 7L by 5. That will be your answer. Okay. বুঝা গেছে? Now instead of taking a wire, now I am taking a closed loop. So same case can also be applied for the closed loop also, because all the points on the loops are moving the same speed. All the points are moving with the V naught speed and all the points are within the same magnetic field also. So you are asked to calculate the potential difference between B and D. So for B and D, first replace this BD wire by a straight wire like this. If I join the BD portion by a straight wire, so this is the potential difference across the BD. Okay. Now, once this wire is moving with the velocity V naught vector, so can I say the L vector is parallel to V naught vector? L vector is parallel to V naught vector. That means the potential difference between VV minus VD, that should be equal to 0. Why? Because scalar triple product, as I have already mentioned, that if any of the two vectors are parallel to each other, then the answer for the triple product is always 0. Okay. So VB minus VD is 0. Now VA minus VC. So for that you have to replace this wire by a vertical wire. So vertical wire is there between the point A and C, whose length is 2R and which is moving with the velocity V naught. And in the presence of cross magnetic field. So V naught cross B, A is the upward, so high potential side, C is the low potential side. So VA minus VC should be equals to 2R V naught into B. That will be your answer. Okay. So across the point A and C, there will be potential difference. Across the point B and D, there will be no potential difference. Instead of taking A and C, if I take any other point, let us say I took diametrically opposite point. Okay. So length of the wire is again 2R. Length of the wire is again 2R. Let us say this is making an angle. This angle is, let us say, theta. Okay. So for that, let us say this is just C and D, not C. Let us say C prime D prime. C prime D prime. So now C prime D prime length is this one. This is the C prime D prime. And it is moving with a velocity V naught. Okay. Length is again 2R. So this angle is theta. Okay. That means this angle is also theta. So what is the vertical component? So that is basically what L prime number. Okay. So what is that L prime number? That is 2R cos sin theta. L prime becomes 2R sin theta. So instead of taking C prime D prime, can I take a vertical wire is there, which is basically C prime D prime, whose length is 2R sin theta, which is moving along this direction V naught. So again the C will be high potential side, D prime will be low potential side. So VC prime minus VD prime should be equal to how much? V naught into 2R sin theta into B. That will be your answer. Okay. So between any 2 points, you can calculate the potential difference. Only thing is that if the points are lying along the V vector, then only it will give the 0 value. Because all the other points will give some potential difference, which is not equal to 0. Okay, which is not equal to 0. So this is all about the standard EMF situation where I am calculating the potential difference with the movement of the conducting wire. Let us say there are two wires P1, Q1. P1, Q1 is this wire. This is the P1, this is the Q1. And there is another wire P2, Q2. P2, Q2. So P1, Q1 is this wire. P2, Q2 is the other wire. Both are moving towards right with a speed of 5 cm per second. So both are moving in this direction with a velocity V. Okay. Resistance of each wire is 2 ohm given. The current to the 19 ohm resistor. So there is a external circuit in which the 19 ohm battery, 19 ohm resistance is there. So you are asked to calculate what is the current through that. So B is given as 1 Tesla. So first, replace the P1 Q1 by a battery. So for this P1 Q1 wire which is moving towards the right with the velocity V, so battery will be so P1 Q1 wire can be treated as the battery like this way. Okay. Similarly, P2 Q2 wire has the same battery. Since both are moving the same speed and both the wire length are also equal, what I can say the potential difference is also same. That is, if I say the V volt battery system is there, here also the V will be there, and this is connected with a external resistance of 19 ohm. Now first calculate the equivalent circuit of this. So if I say the resistance of the wire is 2 ohm, so here the resistance is 2 ohm, here the resistance is 2 ohm. So these two are in parallel combination. So effectively, if I replace the battery system, so what is the equivalent system? That should be equals to one single battery of potential difference V and a resistance of 1 ohm then, and it is connected with an external resistance of 19. So total resistance in the circuit is 19 plus 1 is 20. So what is the current flowing through this? I should be equals to 20 by V. Sorry, V by 20. I should be equals to V by 20. So that will be your answer. So then your task is to calculate the V number. So what is the potential difference across this wire? V should be equals to V into L number. So V is given as 1 Tesla. V is equals to 5 centimeter per second. So 5 by 100. And L is given as 4 centimeter. So 4. So 20 by 100 means 1 by 5. So potential difference 1 by 5. So that is 1 by 100 ampere. So 1 by 100 ampere means if I multiply it by 1000, so it gives how much? 4 by 100, na 4 by 100. So 4 by 100 মানে কত হলো এখানে 5 4 20 by 5, so 500 না 500. So 500 by 20 means 1000, 1 by 1000. So 1 milliampere. তাই না 1000 ফুট ভুল করলাম নাকি না 10,000, 500 into 20, so 10,000. So 1 by 10,000 ampere equals to 0.1 milliampere. So that will be your answer. Okay, বোঝা গেল? এটা. So there is a rod under the presence of the 2 Tesla magnetic field. Rod is moving with a velocity V naught, that is equals to 4 meter per second. 4 meter per second at an angle 30 degree. Okay, at an angle 30 degree. So V cross B should be in this direction. In the direction of V cross B. V cross B. So that is V naught cross B vector. Okay. Now what is this number? That is again equals to VB. Because V naught and the B vector are 90 degrees, so it should be equal to V naught into B. That means this vector is directed towards the A end. So A will be acting as a high potential side, B will be a low potential side, and the length is along this direction. So what is the dot product then? So this angle should be 60 degree. Nah, this angle is 60 degree. So in which direction the length vector is there? So if I say V naught cross B is in this direction, and the L, what is the angle between the L vector and the V naught cross B vector? What is the angle between the V naught cross B and L vector? 90 degree, na? Next. না ভুল বলছি ভি নট ক্রস বিটা ঠিক করলাম ভি নট ক্রস বি এদিকে ঠিক আছে ভি নট ক্রস বি ওইদিকে এল ইজ ইন দিস ডিরেকশন ফ্রম হাই পোটেনশিয়াল সাইড টু লো পোটেনশিয়াল সাইড সো এল ইজ ইন দিস ডিরেকশন এলটা এইদিকে হবে তাহলে ভি ক্রস বি ডট করবো ডট করলে হচ্ছে 90 ডিগ্রি 90 তো পাচ্ছি তাহলে এটা 90 আর 30 মিলে 120 মানে হচ্ছে cos অফ 120 মানে হচ্ছে তোমার মাইনাস থাক তাহলে ভি নট বি মানে কত ভি নট বি মানে হচ্ছে তোমার 4 into 2 into half তাহলে কত হলো 4 হয়ে গেল 4 ভোল্ট পোটেনশিয়াল ডিফারেন্স এ এন্ড বি এ বি 4 এ বি 4 মিন্স অপশন বি না ভি নট বি তার সঙ্গে বি এর সাথে পার্টনার হবে সো ভি নট বি মেকিং অ্যান অ্যাঙ্গেল 90 ডিগ্রি উইথ দ্য ভি নট ভেক্টর সো ইট ইজ 90 ডিগ্রি so what is the angle made by the L vector then 90 plus 30 means 120 okay and which one is high potential side, which one is low potential side, that has to be determined from the cross product. ওখানে কিন্তু ডট প্রোডাক্টের কোনো রোল নেই। ক্রস প্রোডাক্ট দিয়ে আমি দেখবো যে কোন দিকটা হাই পোটেনশিয়াল হচ্ছে, কোন দিকটা লো পোটেনশিয়াল হচ্ছে, এখন আমি সেটাকে মার্ক করে নেবো, তারপর আমি ডট প্রোডাক্টটা করবো। এগুলো করতে পারবে, এগুলো একই গল্প, এগুলো করতে পারবে, অস্ত্রের কিছু নেই। নাও মুভিং অন টু দ্য নেক্সট, লেট আস সে দিস ইজ দ্য সিচুয়েশন। Now there is a conducting wire is placed at a distance of x from a current carrying wire which is infinitely long. Okay. Determine the EMF induced in the rod at a moment when it is at a distance of x from the wire. Now when the conducting wire is at a location, at this point the magnetic field will be cross direction, so that should be equal to mu naught I by 2 pi x. Okay. Can I say that all the points on the wire are under same magnetic field? All the points on the wire are same magnetic field. So I can directly apply this formula. So what is the potential difference? V should be equals to V into L. Now what is V? V is mu naught I by 2 pi x into V into L. Okay. Option A is the correct one. Okay. So if the situation like this way, let us say the wire is not vertical, it is horizontal wire. So let us say instead of taking the AB wire, now which one is the high potential side? A or B? A or B is the high potential side. In this diagram, B is the high potential side because V cross B jokhoni korlam, B is the high potential side and A is the low potential side. Okay. Now instead of taking a vertical wire, if I take the AB wire is horizontal, let us say this is the AB wire that is horizontal, and again the current carrying wire is there, which is infinitely long. Now can I say all the points are acted upon the same potential difference, same magnetic field? No. তাহলে আমরা করব কি, এখন এইখান থেকে x distance দূরে if I take the element of length dx, okay, so there is a small element dx length is there. Across that, what you say, the V is how much? The V is mu naught I by 2 pi. Okay. Now this small dx element is acted upon by the same magnetic field between the 2 points. Okay, between all the points. So for this small dx element, what is the potential difference? So for this dx element, V is cross direction, and the particle is moving, let us say, in this direction, V naught. Okay. So again, V cross B. So towards the A end, it gives the positive potential, here the negative potential. So whatever the small potential difference that created on this element, that element as VV, that should be equal to VVL. So mu naught I by 2 pi x into V naught into dx. Dx is the length. So there is a small potential difference. So total potential difference, that should be equal to integration of dV, and that gives the value of VA minus VV. Why? Because A is the high potential side. So that should be equal to how much? Mu naught V by 2 pi dx by x means ln x. So limit of the rod should be given to you. So let us say the rod length is L and it is at a distance of small a from here, and rod length is L. Okay, so limit should be equal to from A to A plus L. So ultimately your answer, হাই পোটেনশিয়াল সাইডটা বুঝছি কেমন করে, আমি বললাম যে dx যে এলিমেন্টটা রয়েছে, এটা সে দিস দ্য গ্রিন কালার এলিমেন্ট ইজ দ্য dx element. So on this dx element, the magnetic field is cross, and this dx element is moving upward with the velocity of v naught. So what is the direction of v naught cross b? V naught cross b towards left. Nah, v naught cross b direction is towards left. So towards left means this side is the positive side, this is the negative side. That means that side represents what? A side. এটা লেফটের দিকে আছে, so A become positive potential, B become negative potential. Okay, so correspondingly you can get the answer as the potential difference. Okay, if the same vertical wire, let us say this vertical wire is moving in this direction with the velocity v naught. Okay, so what is the potential difference then? Then it should be 0, because now the v vector, velocity vector, is parallel to the L vector. So VV minus VA should be equal to 0. If the same horizontal rod is moving in this direction with the velocity v naught, then also VV minus VA should be equal to 0. Okay, so every time check whether any vector is making parallel to the other one or not. If that is the case, then always write the potential difference as 0. Okay, if the same rod, AB rod, is making the velocity at some angle. Let us say it is not moving vertically, it is moving with some angle in this direction. Now, once the velocity vector is given some angle, take the component. So, y component of this velocity will give the potential difference. X component of velocity will give no potential difference. You don't have to consider the x component of velocity. Only take the y component of velocity and do the same integration. Okay. So depending on different types of geometry and how the rod is moving, the expression of the potential difference will be different. But there are two situations. In one situation, the magnetic field is constant, and in another situation, the magnetic field will be variable. Once the magnetic field becomes variable, same expression can be applied for a small element, and then you have to integrate it